Welcome back. My name is Darren Thomas and I am the Director of Educational Research Techniques. In this video, we're going to continue looking at fraud detection using Python, and we're going to be focusing on how to tune or to make adjustments to a model after you have some sort of initial results. So let's go ahead and see what we can learn. All right, just so you know, we're going to be using the random forest algorithm for this particular video, and we're going to extend what we were doing by we're going to have an initial model that we develop, and then we're going to look for ways that we can tune the model by adjusting the parameters. Now we're going to be doing this manually, and of course there's all kind of ways to automate it, using cross-validation and various libraries that support that, but we're just going to focus on doing it manually this time just for the experience. So let's go ahead and see which libraries we're going to be using. These are the libraries right here. Of course, random forest classifier, that's our algorithm. And then we're going to be using our train test split function to separate our data into testing and training sets. These guys right here are all for checking the metrics for our model. The confusion matrix will give us a crosstabs. Classification report will give us some metrics like recall, precision, and F1 score. And the ROC AUC score, area under the curve, is another metric that can kind of help you to figure out how well your model is doing. Pandas and NumPy will be for preparing our data, and we don't actually need matplotlib, but we'll just leave it there for fun. Let's go ahead and run this. Now we're going to set up our data. We've done this before, and so I don't want to have to reteach everything every single time. But essentially what we're doing in this code right here is we are telling Python to take all of the columns, or excuse me, all of the rows. That's what this colon followed by a comma means. And then we want to take columns 2 to column 29. So the initial numbers are not included there. That's what we're doing. And then once we take this will be our X object. And then we're going to convert that to an array, because that's what our algorithm needs. And then we repeat this process for our Y value. Our Y value is whether or not a particular instance or example is fraud or not. And that's going to be the last column of the data set. And we're also going to convert this to an array. Excuse me. Now, to make these things simple, and by the way, we've used this data many times before. And so again, we're trying to predict fraud, and columns 2 to 29 are all various variables that we can employ to try to determine if something is fraud. This is all pretend data. It's not from any kind of real example. I also need to mention that I loaded the data before the video because it comes off my computer, and so I'm keeping the actual location of the data, a secret for privacy purposes. But you would have to use something from pandas, read SUV from pandas, read underscore SUV, I believe. Now, getting back to here, in this line of code, we're going to be creating our training and our test sets. And so we're making 4 objects right here. The first 2 are going to be X for the X train and test set, and the last 2 are for the Y train and test sets. That's what we're doing here. And so we have to use this function right here, train underscore test underscore split. We use our original X and Y objects that we made in the previous cell, and we set test size to 0.3. That means 30% of the data will be set aside for testing purposes, and the random state is set to 0. Random underscore state is like setting the seed number. So that's what we're going to do. Now remember, if you're not familiar with this, we are supposed to use our test data one time, because if you start to use it multiple times, you're going to start to adjust your data to your test set, and that's not what we want. Again, we're not completely following that step here because we're just trying to demonstrate how this works out, but just keep that in mind. Now we're going to go ahead and set up our model here. And so we're using the random forest classifier, and we're using a class weight called balance subsample. What we're doing is, now remember, when you're dealing with fraud, the majority of the data is not going to be fraud. Fraud is almost like you're looking for outliers, if you will. And so because of that, your model can be highly accurate just through random guessing. Balanced subsampling puts in a penalty in case the model is wrong. And it makes it so that the weights are balanced out so that they have an equal penalty even if there's fewer instances of fraud per se. And so that's why we're doing that. It kind of helps with the model being able to learn when there are few instances of actual fraud in the data. And of course, in the second line of code here, we're just going to fit our data to our training sets. And so let's go ahead and run this. Again, there's nothing to see right now. It's still kind of boring, sorry. Next, we're going to get our predicted values and our probabilities. So let's go ahead and grab that. And so look at what we're doing here. We're going to predict using our X test. So we're still using our independent values, but we're using the test set to try to predict if something is fraud or not fraud. And then we're also going to grab the probabilities by using this function right here. And that's predict underscore prob A. And so we're going to need the probabilities when we want to run the ROC AUC score number, which gives us another way of how much better our model is from just random guessing per se. So let's go ahead and make sure I run this. All right. Now our moment of truth right here. We're going to assess the model, see how well we did. So notice how we're kind of being naughty here a little bit. We're using our testing data already. Again, you will want to try to train your model several times before doing this. So this is not exactly best practice, but we're just learning. So in this first line of code, we're going to use our ROC underscore AUC score, and we're going to use our Y test. So these are our actual values where we know that they're fraud or not. And we're taking something from the object we made previously, probabilities or probs. We're taking all the rows, and then we want to make sure we take the row that has the probabilities in them. And so this will give us a number. Now you can also graph this. And so the closer the value is to 1, the better. And like I said, you can graph this, but we're not going to do that. We don't want to get too far off our purpose here. And so the closer our value is to 1, the better our model is compared to just random guessing. So that's kind of what that's going to be. Classification report. Now this is where we take our predicted values and our Y test values. And that'll give us our precision, recall, and also our F1 score as well as accuracy. And then we're also going to take a look at our confusion matrix, which will give us it's like a crosstab of how well our model did. And so we can actually see how many false positives, how many false negatives, etc. that we got. So let's go ahead and run this. Okay, so here we go. This right here is our ROC score right here. It's 0.96. Now, whether that's good or not depends on the context. It's pretty close to 1. I think we can agree on that. So the model does show some potential there. Precision is excellent, and this is kind of a way of figuring out, well, how good is it at dealing with false positives? So 0.99, again, the highest score is 1. And you can see we only have 1 false positive here. Recall, there's a little bit more of a struggle. That's 0.81. That's dealing with false negatives. You can see we have 17 false negatives. So that's the pain point in terms of where we might want to try to make modifications. The F1 score is kind of a composite of precision and recall. And so that's kind of the most important values for our purposes. Notice how our accuracy is very high. That's because there's only about 90 or so instances, or maybe 75 or so instances of actual cases of fraud out of 2,200, if you will, or 2,190, excuse me. And so that's why it's so high. 91 actually, 91 values, excuse me. And so accuracy by default is going to be very, very high. So what we're going to do now is we're going to take one step forward, and we're going to see if we can determine a way to try to improve the model. And so this is where you have to know kind of what kind of parameters can be tuned for the algorithm that you are using. And so let me just show you what I've already set up, and we can walk through this quickly. Now remember, we're using random forest. So here are some of the things that I've changed. So I set bootstrap to true. And so bootstrap is where every tree that random forest makes is going to be based on a different subsample of the data, pooling with replacement. And so that's kind of what bootstrapping is. The class weights, I changed that. Instead of it being balanced, I made it to where if it's 0, okay, give it 1. But if it marks something as fraud when it's not, penalize it 12 times more. That's kind of what's happening right there. So the class weights are not balanced per se, but there's a much stronger penalty if something is classified incorrectly now. Also, I set the criterion to entropy. This has to do with the purity of the individual nodes. So if you're familiar with how decision trees work, you have it slowly breaks things down, dividing the data until the end nodes are pure, which means like they're all yeses, or they're all no's, or they're all fraud, or they're all not fraud, and there's no mixture there anymore. And so you can calculate a value for that called entropy, which gives you the value of how mixed individual nodes are. And so that's what that's about. And the reason we're setting this is because we're setting the max depth to 10. So there should be at most a maximum of 10 steps from the top down to the bottom inside each individual tree. And so if you don't let the tree work itself out all the way to the bottom, you're going to have a mixture in some of the nodes there. Then we set the samples inside each leaf to be at least 10. Again, we don't want nodes of like 3. That's just too small for practical purposes. The number of estimators is 20. That's how many trees we're going to make. This has to do with the processing power, so set it to a -1. And then the random state is setting the seed. So those are all the things we've adjusted. Again, there's a multitude of ways that you can do this, and there are various ways where you can test multiple different parameter adjustments and look at which combination is the best, but that's beyond the scope of this video. So the rest of this code should look familiar. We just fit our model, get our predicted values and our probabilities, and we're done. So let's run this. Again, there's nothing to see. It's just kind of quiet there. And so now we're going to take a look at our second assessment of the model and see if we're doing better here. All right. So you can see that the values are highly similar to the previous model. Our precision went down a little bit, so we're having more of a struggle with false positives, and you can see that in the confusion matrix right here. Looks like recall is about the same, not a whole lot of success there, still struggling with the false negatives. It went from 17 down to 15, so there is some progress there, but still, not amazing. And of course, our accuracy is still sky high because there's so few instances of actual fraud taking place here. One thing I forgot to mention is the ROC score, which is about the same as last time, not much of a difference. It did go down a little bit, and so you can see how this is playing out right here. So that's essentially the entire process. One thing I need to mention is, notice how we used our test data again. All right, and so this is not necessarily best practice because what's happening is you're slowly adjusting your model to your testing data, and your model should only see your testing data once. So just keep that in mind. I wouldn't want anyone picking up bad habits, through this, but we're just kind of going through the process. So that's essentially everything in a nutshell. So let me go back and summarize what we learned and then wrap up this video. So in this video, what we did was we went through the process of developing a model that is trying to detect fraud, and then we went through the process of how to adjust it. And so we started by, of course, setting up our libraries here. We prepared our data, separating the independent variables from the dependent variable, which of course is the dependent variable is a categorical variable, fraud or not fraud. Then we, of course, set up our train and test data right here. We set up our original model where the only parameter we really set was the class weight, make sure it was balanced. Then we, of course, fitted our model. After that, we got our predicted value, whether it was fraud or not, and the probability that we think that, or how confident we are that particular example was fraud or not fraud. Then we ran our numbers to get our metrics to see how well our model is doing. You can see that right there. And we decided to adjust our model. So we threw in a bunch of different parameters that we could set up besides the default values right here. We set the bootstrap. We set in our own custom value for the class weight, our own value for criterion, the max depth, the minimum number of samples in a leaf, the number of trees to make, how to process it and the random number. We ran it again, got our metrics a second time, and they're highly similar to the first time. So there may not be any benefit to setting all those parameters individually, and we're gonna have to go back and look at other ways that we can try to improve our model. Number one, though, is that we want to try to make adjustments using the training data, and we only want to use the testing data one time. That's very, very important to walk away with. So I want to thank you so much for watching and listening. My name is Darren Thomas. I am the Director of Educational Research Techniques. Thank you so much for watching, and you take care.